Hi there, we're doing checkpoint 4.38. We have a company who determined that their production level is going to be given by the Cobb-Douglas function. F of xy is equal to 2.5 times x to the 0.45 power times y to the 0.55 power. And here x represents the total number of labor in 1 year and y represents the total capital input for the company in a year. Suppose that 1 unit of labor cost $40 and 1 unit of capital cost $50. Use Lagrange multipliers to find the maximum value of this function. And it's subject to the constraint that the total budget is going to be restricted to $500,000 per year. Okay, we have our function already set up, and so we just have to identify our constraint. So we'll put our constraint here, and the constraint will mark it as g of xy, but it's really going to be an equation, a level curve, if we want to look at it that way. And the total number, the total amount is going to be 500,000. So we have a labor cost, which is 40 per labor cost is x, or labor, 1 unit of labor is x, so that's going to be $40 times x, plus you got $50 for the capital times y, and this is supposed to be equal to 500,000. So that's our constraint. Now let's set up our Lagrange multipliers. We're going to need to figure out our gradient. So the gradient is going to be, with respect to x, it's going to be 0.45 times 2.5. So we got our calculator here, 0.45 times 2.5. That's 1.125, and we'll have x to the, subtract 1 from here, that's negative 0.55, and y is equal to, or y raised to the 0.55 power. Okay, next we're going to take the derivative with respect to y, but this time it's going to be 0.55 times 2.5, and that's going to give us a 1.375 x to the 0.45, and we're going to subtract 1 from the power. That's going to give us a negative 0.045. Okay. Our gradient for g is going to be just simply constants, 40 in the x direction and 50 in the y direction. Now we have our equations that we're going to set. We're going to multiply this by lambda, so we will have a 1.125, and let's write this as a fraction. Let's say y to the 0.55 divided by x to the 0.55 power. This will equal to the first component of g multiplied by lambda, and then we'll have 1.375. We'll write it again with positive powers. That's x to the 0.45 power divided by y to the 0.45 power, and this is going to equal to 50 lambda. So between this and the original constraint equation, 40x plus 50y is equal to 500,000. We have 3 equations and 3 unknowns. We really just care about the x and y unknowns. We don't care so much about the other guy, the lambda. So why don't we take a look at combining these 2 equations. We'll multiply maybe the first one by 5 and the second one by 4 so that we can have matching right-hand sides, and then we'll set them equal to each other. Okay, so I think multiplying this by 5, I would need to know what, and we're going to multiply this by 4, so maybe we'll do the bottom ones first since that's already in my calculator. So let's do times, oops. Can we just put times? No, we have to put the answer times 4. We're going to get 5.5. So this would be 5.5 x to the 0.45 divided by y to the 0.45, and that's going to equal 4 times this is 200 lambda. And then if we multiply the first number, that would be a 1.125, and we'll multiply that by 5 this time. It's going to give us a 5.625 y to the 0.55 divided by x to the 0.55, 0.55. And since these are both equal to 200 lambda, I can set them equal to each other. So let's set them equal to each other. We're going to get 5. Let's try that again. We're going to get 5.625 times y to the 0.55 divided by x to the 0.55 is equal to 5.5 x to the 0.45 divided by y to the 0.45. Okay, now we have a relationship between x and y that we can combine. Let's multiply both sides by y to the 0.45. We'll add the powers. That's just going to give us y. We'll also multiply both sides by x to the 0.55. And here we will have 5.625 y is equal to 5.5x. And just a matter of dividing by one of them. Let's divide by 0.55. So divide by, or 5.5. We're going to get x will equal to 1.02272. 7, let's go with that, times y. Okay, now let's take this, put that into this equation. We're going to get 40 times 1.022727 times y plus 50 times y is equal to 500,000. And let's go ahead and multiply that by 40 times 40. And then we will go ahead and add 50 to that. And so that's going to be the new coefficient of y. We have 90.909091. Y is equal to 500,000. Okay, so we'll take 500,000 and divide it by that. 500, 1, 2, 3, divided by the answer that we just got. And we get 5,500. Y is equal to 5500. Okay, so that's how much capital we need to maximize, and we will simply put that back in here to get our x value. And so we'll take that number y and times, we got 1.022727, and we get x is equal to 5624.99. So we'll go ahead and go 5625 with that. And so the maximum happens. Max is attained with about 5625 units of labor. That's the x. And y is equal to 5,500 capital. And of course, they're probably going to want to know what is the maximum value of f. So f of, again, this is the x, 5625, and the y is 5500. And that we can just punch in. So this is our x value already. Let's go ahead and multiply this, or take this to the 0.45 power. That's the x is being raised to 0.45. Double check. Yep, 0.45. And then we'll multiply the y, which is 5500. We'll raise that to the 0.55. And then we'll go ahead and multiply everything by 2.5. And I get 13,889. So 13,889.75-ish. All right, so that's it. It'd be interesting to also see this in a graph. So I would highly suggest that you try to graph this using CalcPlot 3D. You might need to do some adjusting for the domain. We want to include the 5,500 and 5624, and so that's going to be a really huge domain. So if you can find that and adjust it a certain way, that would be great. Okay, good luck.